Ciao ladies and gentlemen. In this video we're going to solve these two simultaneous equations that you see here. So simultaneous equations is all about finding where these two equations meet on the graph, or what x and y values, which make up a point, work in both of these equations. So we're looking for the same x and the same y that will make both these equations work. So in order to do this, the fact that we're interested in where these equations meet means we need to combine these into a single equation. So you have to be careful about how you combine them, because if you go ahead and bring them together in such a way that you still have two letters, you will create an equation that you can't get one specific solution for. So here we're looking to try and eliminate one of those variables. So we want to either add or subtract these equations together to make one of the letters disappear. So as you look at it, if we look at the x's first of all, if you add or subtract them from each other, nothing's going to cancel. But the y's, have to be careful with this. If you have a y plus a minus y, that gives you a y take away y, which will disappear. So that's what we want to do. We want to add them. Just to show why taken away wouldn't work, if you have a y minus a minus y, that then becomes a y plus y, which gives us two y's. It's not gone away, okay? So we want to add these two equations together. In general, if you have two letter terms that are exactly the same as each other, except one's a plus and one's a minus, you want to add these together, okay? Now, because of the fact that we're going to be adding them together, we also have to add everything else that's in this equation together. Effectively, you're doing the left-hand side plus the left-hand side, and the right-hand side plus the right-hand side. So our y's are gone. Like, we're going to get big fat 0 there. We don't even need to bother writing it in. On the left-hand side here, or the furthest left, we've got a 2x plus 5x. They combine to make 7x. And on the right-hand side, we're going to have 5 plus 9 to make 14. What you now have is an equation with only one letter in it, which means we can actually solve it to find the answer. Divide both of these sides by 7, and we will get x equals 2 as our answer for x. Now we're technically only halfway there as far as answering the question's concerned. Of course, we've done a little bit extra work, but we need to solve for x and y. We need to find out what numbers for x and y make both of these equations work. So x equals 2 is one of our answers. We've got to find the other one. In order to do that, we have to substitute this x equals 2 back into one of these equations. Now the truth is, it doesn't matter which one you plug it into, because when you merge them together, you were solving for where they meet. So it's going to be the same answer both ways. That's why it's going to work for solving both equations. Always pick the one that looks the nicest. I would choose this one because of the fact that you got a plus y instead of a minus y. You could also argue because these numbers are smaller. You know, it's your call which equation you plug it into. There is no real right or wrong answer if you chose the other one. Okay, so we have our we have 2x, so this x is going to get replaced by the 2 that I've got in green. Bit over the shop here with the colours, so bear with us. So we're going to have 2 times that 2 that went in there. We're then going to plus y, and that equals 5. Tidying that up, we're going to have 4 plus y equals 5. And then take away 4 from each side to get y by itself. Y is 1. So our answers are x equals 2 and y equals 1 together. You can write them one above each other like this. You could also leave it the way I've done it with them two boxes separately, but I like to put them together like that. On any other question, if it asked you for the point of intersection, you could also write this answer as an actual point, 2, 1, but in this instance it's not needed. That would be our final answer.